The graph of f of x equals x minus 1 divided by x squared plus x minus 2 is shown below. What is the domain of f of x? There's the graph. Let's go. Okay, you can do this problem by understanding what the domain is and looking carefully at the graph, but I also want to show you why the answer is what it is, because that might help on another problem if they don't give you the graph, which they may well not do. But okay, we've got this function and they're asking us what's the domain. First of all, what's domain? Domain, and this is a definition you really ought to remember, so write it down. The domain is all of the allowable inputs to a function. You may think of the domain as the x's, and in many cases that's a good way to think about it. But think of it this way, it's all of the allowable inputs to a function. What I mean by allowable is this. I can plug in any number I want into most functions, right? It's a free country after all. I could plug in 5, I could plug in 15, I could plug in 1776, right? This is America. We can plug in whatever we want. But I can plug in basically any number I want into a function, so all those numbers are in a domain. However, there's one rule that I can't break. Even George Washington himself can't break this rule. We're not allowed to divide by 0. That just doesn't work in math. So the idea here in the domain is I can plug in anything I want as long as it doesn't mean that I'd be dividing by 0. That's the thing I can't plug in. So in our particular problem, we're saying I could plug in any x I want to, but I can't plug in an x that makes the denominator turn into 0, and that's the key. So let's look at this function here. I'm going to write it out. We've got f of x equals x minus 1 in the numerator, and then the denominator is x squared plus x minus 2. I can't have a 0 denominator, so what I want to do to figure out which values of x make the denominator 0, I want to factor the denominator, and you should do the same thing. Numerator we're going to keep, x minus 1. The denominator, we have to factor the quadratic, and you can use all of your factoring techniques you've learned before to do this. It's going to be x and x, and then I'm looking for two numbers that multiply to -2 and add to positive 1. And those two numbers would be a plus 2 and a minus 1. So if I factor the denominator, I get an x plus 2 times an x minus 1. Okay, well now I can see for myself what happens here. X plus 2 is one factor, x minus 1 is another factor. If x is -2, we're going to have a problem. Because if x is -2, that means this factor is going to become 0, which means the denominator is going to become 0, and we can't do that. Remember, George Washington himself can't divide by 0, even though this is a free country. So we can't divide by 0. X can't be -2 as a result. And how about this factor over here? Well, x can't be 1, because if x is 1, then that factor is going to be 0, and so the denominator is going to be 0 once again. So x can't be -2, x can't be 1. And if I look at the graph, take a look. X can't be 1, that's evidenced by this hole right here. So x can't be 1 is the reason we see a hole in the graph right here. And the fact that x can't be -2, that's why we get this imaginary dotted line called the vertical asymptote. That's why we can't get x is -2. That's why we get the dotted line here in the graph. X can't be -2, x can't be 1. Those are the restrictions in our domain. So the way you do this is you look for where the denominator is 0. Those are the reasons we can't have those x values in the function. And those are the restrictions, which means our answer here is D. X can't be -2 and x can't be +1. And if you got that, good thinking.